So today we're going to kind of make sure that we're all sharing the same language with the PWR Act. We're going to be kind of talking about that philosophy of transitional math and transitional coursework in general. And then we're going to specifically take a look at that competencies and policies document to take a look at what this course should look like. Next week, we're going to be talking more specifically about our community college partnerships. We're going to be digging into some of the documentation and the approval process. Some of you might have heard of our local and our state portability panel. So we'll be talking a little bit more in depth about that, and I'll be giving you some resources to take a peek at ahead of time. And then in our last session, we're really going to be talking about some of those instructional shifts and sharing some great resources, including our own transitional math state level resources that we have to help you with implementation. Today, I'm going to challenge you to reflect as we move through our conversation. So these are all of the moving pieces we're going to be talking about. We're going to be talking about that partnership that you feel really strongly about. I want to know what it looks like. We're going to be talking about who those transitional math students are, how we're identifying them, how we're preparing them for what their future holds. What does that experience look like? So I want to give you just a moment to take a look at some of these reflective questions and kind of get a compass point in your head as we prepare to engage in these conversations. The reason why I put this first is because it underpins and sets the stage for our entire belief system and philosophy on transitional math and transitional coursework. It was one of the first places that our local partnership started. And we said, who are our students? What are we trying to accomplish? What does this look like? So I'm going to ask you to think to yourselves right now, who are your transitional math students? And I'm going to take it a step further, and I want you to think about a student. Now, we're going to get into the logistics of identifying these students a little bit later, but from a conceptual standpoint, can you pick out a child, a student, who would benefit from transitional math? I'm going to just let you kind of percolate on that for just a second. And I would share with you, if you can't think of one, I will share my own with you. So please, if you know my daughter, you can go ahead and tell her I did this to her. I'm sure she'll be sufficiently embarrassed. But this is my daughter. Her name is Mackenzie. And what you see here are snapshots of Mackenzie as she has kind of moved throughout her educational career. Just so that you know, Mackenzie was actually in accelerated coursework for mathematics at a very early age. She was very strong procedurally and didn't have any problem with her math learning or her math education until probably right around 8th grade. And around 8th grade, the math started becoming more complex and it shifted more toward application and really kind of started building on itself. And her procedural skills and her procedural fluency could not continue to support her growth as the math became more complex. So as a result, she struggled with math her freshman, her sophomore, and her junior year to the point where she was working with private tutors, exiting the accelerated track for mathematics in order just to keep her head above water. So her junior year, you'll see there, Mackenzie went to the vocational center to become a CNA only because I said college is a really expensive career exploration endeavor. And if she wanted to be a nurse, which was her career aspiration, she had to go and get her CNA license at our local vocational center. So she did. And she was very interested in her senior year taking some dual credit math at the local community college. But she didn't have the grades and could not pass the placement exam to get into that course. So as a result, she did not have any math her senior year. And as she transitioned to the community college, her plan was to go a 2 and 2 to get 2 years under her belt and then go to a 4-year institution and major in nursing. She could not place into credit-bearing coursework for math. So she got stuck in the developmental math cycle and attempted the course at least 3 times before she successfully completed it. In the interim, her confidence throughout the latter portion of her high school career and into college was pretty much decimated. She began questioning if she couldn't understand how to do mathematics, how she could ever be successful and take care of patients as a nurse. She lost interest in going to a 4-year institution and planned on working in retail and living in my basement. And we had to have a candid conversation with one another, and really had to work very hard at completing that developmental programming to get into credit bearing coursework. She did, if you see on that far right picture, she did actually, she graduated from the community college and went on to Illinois State University. Her new major is social work because, according to her, it doesn't require a lot of math, which we had to smile about. And she graduated this past August with as a certified family life educator. So there is a success story out of this, but there were a lot of bumps along the road that were really discouraging and disheartening to her, and really kind of took her off of her career path, and put her into kind of this no man's land. Um, and when I think about the kids that we're doing this for, this is who I think about. This is what wakes me up in the morning. This is what makes me believe so much in the coursework and the philosophy of what we're doing with transitional math, and ultimately transitional English language arts. Giving those kids a chance to engage in a different way, giving them a different experience, building their confidence as well as their math skills. If you haven't had an opportunity to access some of these documents, these are resources that you should love, know, sleep with under your pillow. I use them quite a bit. So there is the hyperlink there to give you access to that competencies and policies document, but we're going to kind of use that. And by the way, on ensuing slides, I've tried to hyperlink that into some of this as well, in case you can't hop back to that first slide. So the competencies and policies document, and I will tell you, Transitional English went through a very similar process. Um, there were groups of math educators that from across the state that got together in 2017, and they really sat down and talked about these core competencies for math in 3 different pathways: technical math, STEM, and quantitative literacy and statistics. And so they really talked about what's important, what pathways are going to result in what careers, what knowledge and skills do students need for each of those, what is the expectation. So this document was crafted as a result of those conversations. I will tell you, much like English language arts, it did go out for public comment and feedback. And so there was this dynamic kind of 2-way conversation in crafting this to make sure that all voices were heard and represented in putting all of this together. So in this document, if you haven't had the chance to take a look at it, there's different information that is presented. It's great information. The front matter of this document really kind of talks about the philosophy of transitional math, and it also more, I don't want to say more importantly, but probably most importantly, and I think it's oftentimes overlooked, is it articulates those process competencies. So next week, when we talk about documentation, some of the documentation you're going to have to submit for approval and portability is going to relate to how do you incorporate those process competencies, because that's where we get the shift. That's where we kind of get some of those great instructional strategies and engaging those students who are reluctant math learners. So if you look at the document, or if you look here on this slide, some of those process competencies include our standards of mathematical practice, which we all know and love. But we also have some other competencies that we would really like to see our students engage with, related to personal ethics and work ethics. Are they able to effectively communicate and work in teams? We do a lot of work with manufacturing in our area, and our manufacturers continually tell us we need people who are able to communicate and get along with one another in the workplace. They need to be able to show up on time. They need to be timely in their communication and responses. So as we're building this, we're kind of taking all of that into consideration as we craft the learning to pull on these competencies so that we're preparing students not only for their next step in education, but also for employment and for life. So these are very important competencies. I will tell you, I was fortunate enough to be engaged in the Transitional English Language Arts group, and they too believed very strongly that these process competencies, these habits of mind, are so important for our students, not only in math, but in other disciplines as well. You are also going to notice when you flip through this document that when you get to the actual competencies, it's divided into 3 different sections. One for technical math, which I can tell you really focuses on the number system. It has some very basic algebra and geometry involved. So you might think of students who are going to become technicians. Perhaps they are going to work in manufacturing. Maybe they're going to do something with the culinary arts. So maybe some of our vocational programming, those would be the students who would be great for technical mathematics. Quantitative literacy and statistics. So the focus there is numeracy. You've got a little bit higher level of algebra, and then we're going to get into functions and modeling, which is a lot of fun. And then finally, our STEM pathway is all about the functions and function families. And so that one was particularly exciting to work through, because when you get into some of those functions and function families, it becomes a challenge even for ourselves as educators to think about, when would students use this in real life? So when we get into the piece about the resources, I think what you're really going to appreciate is the fact that we've already identified those for you. So we don't have to kind of rack our brains as far as what that might look like. This is a competency-based, or I should say, these are competency-based courses. Okay, so when you look at the document on the left-hand side here, these are the competencies. For this example is quantitative literacy. So the competencies are here on the left. Those are those broad statements of a learning goal. What is it that students should be able to know, do, understand? What does that look like? On the right-hand side, we have what are called key performance indicators, or KPIs. And those KPIs are those finer grain size look-fors. So if we say that a student can apply, analyze, evaluate the characteristics of numbers in authentic modeling and problem-solving situations, what are some of those things that we should plan for intentionally in our curriculum assessment and instruction? And how is it that we're going to collect evidence of learning that those students have mastered those key performance indicators to be able to make the claim that they have met the competency? So they feed off of one another. And again, when we get into some of those resource conversations, you're going to see that all of the resources are aligned to a KPI as well as to a competency, so that those of you who are going to be teaching the course have some really direct connections. Your portability submission will also ask you, what tasks have you developed, and what does that look like in your course? Because we want to make sure that everything we do is competency aligned. So this plays into our conversation for next week as far as documenting the process. One of the very first things that we did, both locally and at the state level, was to go through and read the competencies and the key performance indicators and talk about what that looked like. So we had a common language. So if you haven't done that in your partnership yet, it's such a great experience between secondary and post-secondary. I would encourage you to do that. So let's talk now about who we enroll. So we talked a little bit earlier about, from a conceptual standpoint, who's that student? What are we preparing them for? But now, from a logistical standpoint, who do we enroll? So, oops, I think we have a piece of text on here. I'll have to problem solve how to get that off. But this will be available to you as a hyperlink. This is actually from the iltransitionalmath.org website. And it is a flow chart, which I think is pretty handy to be thinking about your students that you would enroll in this course. Now, as we're going to dig a little bit deeper, and as you probably heard John talk about, this is a fourth year math course that can be used for either high school graduation credit or portability, not both, right? So if they have not met their high school graduation requirements, that is a whole other conversations. Now there is an option for that, and we'll talk about that in just a second. But thinking about that identification process is something you're going to want to talk about now, because you're going to want to recruit, and you're going to want to put this on your books for registration after the first of the year. So how do you select your students? How do you recruit your students? So one of the very first questions we have to ask yourself is, does the student meet those high school graduation requirements? If they do not, they have to make sure that they have that high school math credit for graduation purposes. Now they can enroll concurrently in a course for graduation credit and the course for portability. So they'd have to take 2 math classes their senior year. Now we know that that is sometimes a tough sell, especially for those we just talked about, those students who lack confidence and are a little bit disillusioned with their math educational experience. So that might not be a very easy sell for some of our students. But if they have not met those graduation requirements, it is so important that they do so. Otherwise, they can't get portability. Okay. So we're going to be looking at some indicators if they have met those requirements. So we're going to be looking, do they have a B or better in Algebra 2? They should be able to meet at least 2 of these. Okay. We're looking at it, that language is outdated. You see a Park score, and we're not doing that in high school anymore. We are looking at SAT, when we might be looking at their GPA. In other words, we have a system for identifying these students who need it, who are in danger of not being college and career ready in math. Okay. So if the student meets 2 or more of those indicators, then we're going to say, okay, they have a fighting chance at being college and career ready. Can they take that course? Sure. They can take transitional math. They might not need it, but taking a 4th year math is better than not taking a 4th year math. If they are lacking in some of those college and career readiness indicators, if we're seeing that they have 2 or fewer, we're really concerned, then they would qualify for that transitional math. And I use the word qualify personally from Angie Garza's standpoint, maybe a little loosely. I would think that that would be a sign that it would be just a good fit, right? Because if one of the things we're discovering in our rural communities is it's hard to fill seats in some of our courses. So, opening that up to students who maybe just need a 4th year of math might be a good thing to do. And it certainly wouldn't harm those students. Taking a year off of math, there's a lot of learning loss with that. So kind of think about how you would use this to recruit students. How could you sit down with a team at the high school level? And we're going to want to do this as early as their junior year to start getting them to think about their senior year math options to make sure that they're college and career ready. So think about how you might use this decision chart to do that. This is another resource that's available on the iltransitionalmath.org website under guidance for counselors. So this is really, in addition to our math folks and our math teachers, our guidance counselors, you guys are going to be our front line with this and communicating with students and their families. So this is a little bit more information about each of the pathways and what students would be best suited for which pathway. So again, this fits very nicely into our career pathway endorsement and our PACE framework, because students probably also need to have an idea about what they want to do with their life, where they want to go next, in order to make appropriate decisions with regards to their transitional math coursework. But this in and of itself, these 2 tools are very helpful, especially in those counseling situations where you're trying to get the student to sit down and think about their future and what they need to be successful in that future. So let's talk now for a few minutes about this idea of a different experience. And then I'm going to let you talk a little bit amongst yourselves. So I'm going to walk you through a couple of research pieces and then a task to kind of illustrate how this is a different experience for kids. And so we've started a lot of our transitional math sessions with this image. And so really what we like to talk a lot about in transitional math is this idea of cognitive load. So when I say cognitive load, I want you to imagine a personal trainer. I have a friend who was a personal trainer and who really enjoyed making me work and making me hurt. And so if if I had my personal trainer go in and do all of my exercises for me, who would be getting the benefit of that exercise? Obviously, it would be the trainer. So we want to shift that load back onto the students. And so this data here is representative. I think it comes out of the New Teacher Project. There was a study conducted that students who engaged in coursework that even was grade appropriate, there from an instructional standpoint, there were it was over scaffolded or structured in such a way that the students didn't have to do any of the thinking. So you see here that out of those 900 lessons, only 295 had grade level content. And only 74 of those assignments had students looking at grade level content and asking the students to do the thinking. We're going to talk a little bit more about that in session 3 with instructional strategies, about how we put that cognitive load on the students. And honestly, this is a message not just for transitional math, but for instruction in general. We should all be doing this kindergarten through 12th grade. Students should be doing the lifting. We also know that if we look at Visible Learning by John Hattie, one of my favorites, there are some pretty high leverage strategies that Hattie cites that are engaged with this new experience of teaching in a task-based fashion through our transitional math courses, including problem-solving teaching, classroom discussion, and so forth. So remember, Hattie's got that hinge point of 0.4. Everything we do has an impact on a child's learning and achievement, but that hinge point is 0.4, where we can really see the impact of that achievement and students growing 1, 2, 3, even grade levels. So anything to the right of that is a high leverage point. So when we are shifting the load, we want to create tasks that are allowing students to reason, problem solve, and there's not really any kind of clear right answer. It's not a gimme. We're not over scaffolding. So we came up with, as a team, when we were creating some of the resources for this, we came up with a list of things that we would expect to see in a great task. And tasks, if you look at any of the state level resources that we've provided on our iltransitionalmath.org website, it's all task-based. It's all task-based instruction where the cognitive load is put on the students. By the time kids get to high school, the classic question is, when am I ever going to use this?
Yes.
Right? So we have to provide that reason. We have to provide that problem, that situation, that part where the math is the mystery. We really want that answer to that question, but in order to do it, we have to do the math. So I think that is pretty powerful. That and this idea that there's not a lot of over scaffolding and there's lots of opportunities for students to contribute. That's really going to help students build their math confidence and move forward with that. Thank you for sharing that. I want to very quickly kind of tell you about one of the tasks that we have in our quantitative literacy and statistics course. It's one that I share all the time because it's my absolute most favorite. When we do our remote session, I'll kind of talk with you about how I would do this from a remote standpoint, but this is our hurricanes tasks from QL. So I always start with either some footage of a destructive hurricane, and I have the students talk about what they know about hurricanes. So we're automatically leveling the playing field. It's not about math. It's about students noticing and wondering and really kind of getting some baseline information about hurricanes. Then I give them a data set and I ask them to just look at that data set and tell me, what do you notice? What do you wonder? What is this data telling us? So they're using lots of different headings. They're having to look at how the data is organized, and we're low threat right now. What do you notice? What do you wonder? What are you thinking? Nobody looks silly. No one has to put themselves out there mathematically. There's multiple right answers. Okay. Then we're going to layer in a little bit of literacy. So students have generated some questions about maybe some things they're wondering about hurricanes. Now we give them the opportunity to do a little bit of reading and answer those questions. We're establishing a purpose. We're establishing a purpose for learning more. Then we ask them, based on the question presented in the article, what are we compelled to answer? And if you look at the article, the question is, are female hurricanes deadlier than male hurricanes? And one thing I did forget to mention is before I even show them the video, I give them a survey about evacuation protocols and if they would be more likely to evacuate for Hurricane Victor or Hurricane Victoria. So we've already activated also some prior knowledge. Students are then asked in their groups to do a statistical analysis of their data set, and they can use any tool in their toolkit. They can represent it in any way they want, but they do have to construct an argument to answer the question and use that analysis as their evidence. And typically we have them post this around the room, and then we have people share. We do a wall walk where students walk around and they ask questions and they make connections between data representations. And then I also try to intentionally sequence the sharing. So I start with the simple models first and I move up to the more complex, which builds those learning hooks, those cognitive hooks for kids to grow their mathematical knowledge and understanding. And then we do some extension activities. So we take that data, that raw data that we've collected from the students in looking at their bias about male and female hurricanes, and we ask them to analyze and represent their own data. And this could be done independently or again in small groups. So as a class, are we more likely, do we have a bias on the name of a hurricane and whether or not we are likely to evacuate and save our lives? So that is an example from QL. I always act as the facilitator. I am not feeding them anything. We're not over scaffolding. And we have lots of other great examples that we're going to be sharing with you, including some farm to table. There's a great crime scene investigation about blood splatter. We've got information about tuition costs and buying a house, and other really wonderful tasks for students to engage in that are authentic and meaningful and really, really messy. We talked a little bit about a different experience and we talked about recruiting students, but I also want to remind everybody about this idea of equity. So equity should be that lens that we're using for everything. How are we creating opportunities for all students to engage in this work? And what does that look like? So I would encourage you as you take some of these conversations back to your local partnerships to keep in mind that equity component. It's so vitally important that we reach all of our students and consider all of our learning populations in order to promote equitable opportunities for all kids to be successful and to grow and to find their passion. So please remember that. When we think about a new experience and we think about the work that's ahead of us, I want you guys to think about curling. My father asked me one time if I knew about curling and if I played curling, and I said, no, Dad, but it's a great analogy. And so I want us to think about the fact that our students are the stone, and you always throw the stone at the target. The target is our competencies. So our role as we think about this new experience is we are the players on the ice with the broom melting the ice to influence the direction of the stone. We're not picking it up and taking it over and putting it on the target. We're keeping that cognitive load on and we are melting that ice such that the student eventually meets that target.